Okay, hey. So yeah, today we will have a new pattern for the class. Today we first discuss the questions quickly, then we will be open for your doubts. Actually, today I created a webinar instead of interactive class, so I think you are all are not able to unmute yourself. Okay. Hey Manish, am I audible? Can you speak something? Fine. Yeah, this is the issue. You're not able to unmute probably. So yeah, today we'll discuss all the questions first, right? And then we will be open for discussion, open for your doubts, right? Yeah, we try to be as explanatory as possible when needed. So this is the first question of the contest. Here it says we are given two arrays number n1 and n2, right? And in this two arrays, what we have to do? We have to tell how many values are there in number one, which are also there in number two. We have to return the count C1. And how many arrays are there in the array two, which are also there in array one. Return the count C2, right? So we have to return this as the output. Basically, if you see in this example, right? Here four. Four is not there in this array. Three, three is there. So one, two is also there here, right? So one more. Incrementing the count. Then again three is also here, incrementing the count. One is not here. So we have three values in this array which are there in number two, right? Similarly, if we count for this array, right, you get four. So 3, 4 is the answer. It's a quite a simple question, and here if you look at the complexity, right, it's 100. Size of the array is 100. So you can just do a basic brute force, right? What will be the brute force? Very quickly say you, right? Like if you can iterate each array, right? Find number one, right? If number one of I is in nums2, right? Then you can increment the count C1 plus plus, right? Similarly, you can do for the other part, right? For I in number two, if n2 of I in number one, then increment the count C2 plus plus, correct? Then you have to return what? C1 comma C2, an array. A basic code will work here. And if you write a basic brute force set, complexity will be 100 into 100, 10 to the power 4, which is quite acceptable. So I think this was quite an easy question, right? And if you have any doubt here, then you can ask at the end. Fine. So yeah, moving on to the next question. Okay. Okay, fine. And this seems to be a good question. Yeah, let's quickly read it. You're given a zero index string word. In one operation, you can pick an index I of word and change the word I to any lowercase English letter. I think this is quite understandable, right? In one operation, we can change any character of the word, right? To any lowercase English letter from A to Z. Find the minimum number of operations. They need to remove all adjacent, almost equal character from the word. Okay. Two character A and B are almost equal if A is equal to B or A and B are adjacent. Okay. When are two character equal? When they are equal by default or they are adjacent. By adjacent we mean see they are saying yes. Let's say A and A. These are two equal character, right? So they are in almost equal. If you say A B, they are also almost equal. Why? Because the gap is one. Like they should be adjusted. Like C D, they are almost equal. C E, they are not almost equal. Why? Because C and E have some gap. We say about X Z, they are not almost equal. X Y, they are almost equal. If two character D D, they are almost equal. When the two characters are almost equal, when either they are same or they are adjacent. Okay. So in the given word, right, you have to remove all the almost equal character. Let's say how to remove. Okay. So here let's see we have A A. They are almost equal, right? They are almost equal. So ideally, what should you do? You should change anyone. Obviously, you have to change anyone to not make them almost equal. Let's consider a basic case, right? Let's say we have A B, right? Let's say brute force. What will we do? We go here A and A. Are they almost equal? Yeah, they are almost equal. So we change A to set some character B. We cannot do. Why? Because A and B are also almost equal. Correct? So we change it to C. Fine. AC. Okay, now they are not almost equal. They are good. So moving ahead. CB. Okay, they are almost equal. So we should change C to anyone. We can change C to, sorry, we can change B to A. It's fine. Okay. Now ACA, it's a fine string. It doesn't have any adjacent character which are almost equal. But here we did two operations, right? We changed the second and the third character. Rather, if we would have done a single operation, right, better answer would have been A, D, B. Like if we would have changed this A to D, right? The A, D are not almost equal. D and B are also not almost equal. So this sounds a better operation. So how should we do? In my opinion, right? A, B, correct? What should we see? A and A. Okay. A and A. So are they almost equal? Yeah. So here we have no option. We should always change this one, right? Because why should we change the first one? Because one operation you're doing anyhow. So changing this may contribute in this answer also. Because if you change this one, let's say you make this B. Now again you have to change the second one, right? But if you change the second character, you have an option, right? So first character we should not change. We should change this one, right? Okay, I change it to B, let's say C. Now these two are shorted, right? So moving here, DB. What will you say? CB, they are not good, right? So you should change. Now, which one you should change? C was already changed before, and B is never touched. Which you should change? Obviously C, because since you have done already an operation on C, since you have already done an operation on C, right? If you do one more operation here, that will be counted as a single operation. Let's say you make it D. Okay. So, and then what's the result? You had the string AAB, or you have ADB. The result is although you applied operation here two times, it could have been done if you would have applied the operation one time. It's equal. It doesn't make any difference whether you apply at the same place operation 10 times also it's counted as one operation. And then what is your final goal you have there? Getting my point, right? So that was the overall point of saying this one. So yeah, this change is also allowed. So I think this makes it clear. How will we proceed? Okay, let's say how we should we proceed. Let's say this one. Okay, we want to change the minimum number of operations. We have five here, right? We go character by character. A. These are almost equal. So we should change. So we should change this one, right? We should change this one. Okay. Now going ahead. These two. Are they almost equal? Yeah. But you will say, sir, we have changed this one. Okay. We have changed it. But someone will say, sir, maybe we have changed it to B itself. So maybe there may be any case, but we have changed this. Now, what will you say? They are almost equal, right? So we should change this one character, right? Which one should we change? This one or this one? Obviously this one because this has already been changed once. Okay. Now moving ahead. These two are they almost equal? Yeah. So which one you should change? This or this? Because you have not changed either. Always obviously you should choose the next one because this one won't be used by this one. For this one, we use this one. So basically we should change this one. We change this one, right? For sure. What we are changing to be least important because we don't have to return the final string. We have to return the number of operations. Now going here again, A. So again these are equal. So this needs to change. Which one should we change? So because this was already changed before, right? So yeah. Now we have two changes and we have the final string which is a different one. So answer is two. You got my point, right? Just we have to keep a track of whether we are changing a character or no. Okay, moving ahead. Let's be very clear here. A, B, D, D, E, Z. Okay. So this character we never change. We never change the first character because there's no use. Okay. Okay. Now we go to this one. So is the first character changed? Are A and B almost equal? Yeah. So which one should we change? Second one, because we have two options. Either the first change or the second change. So first was never changed. So we should never touch it. We should change the second one. We change this one. Fine. Going ahead. B, D. Are they same? Are they almost equal? No, not almost equal. D, D. Are they almost equal? Yeah, they're almost equal. Now, was this one changed before? No, this one never changed. So we should change here because they are almost equal. Which one we should change? Obviously the second one because the first one was never changed. We change this one. No other option, right? Okay, now moving ahead. D. Are they almost equal? Yeah. So we should change one. Was the first one changed before? Yeah, it was changed before. So we can change again this one. Yeah. No, it's fine. Moving ahead, EZ. Are they almost equal? No. So how many changes we did? Two. You got my point, right? Let's do it again once here. Okay. Here we say we have ZY. ZY. Are they almost equal? Yeah. We should change one. Which one should we change again? The first or the second one? Which was never. We should change the one which was never changed before. Which was never changed before? First one was never changed, and second one was never changed. And when we have a conflict, right, when both are never changed, we should change the second one, right? We change this one. Okay. Y and X are they almost equal? Yeah. But which one should we change? Y, because this was already changed before. Fine. Good. X and Y are they almost equal? Yeah, they're almost equal. Which one should we change? The first or the second one? Obviously the second one, because the first one was never touched. We should never touch the first one. Again, Y and X are they almost equal? Yeah, they're almost equal. Which one should we change? First one, because first one was already changed before, so changing this won't cost an operation. Okay. Now moving ahead, X and Y are they almost equal? Yeah. Which one should we change, first or second? Obviously second one, because the first one was, if the first one was touched before, we should touch it, else we should prioritize the second one. We change the second one. Why? The last one, Y and Z. Are they almost equal? Yeah. Which one should we change, first or the second? Obviously the first one, because the first one was touched before also. Over. We did three changes. Got my point? I think my point is pretty clear here. You have to keep a variable, let's say flag false, something you can keep, right, and you can compare to character. You can make a function is almost equal, right? So basically you can iterate like this for I equal to 0 to second dash character, right? If almost equal, right? Almost equal, you can give a function. You can pass a of I and a of I plus 1. If they are almost equal, sorry for my handwriting. Then what we should do? We should check, right? Like this is the answer, 0. So if we have a flag, let's say false, right? The first character is never changed, right? Flag means that the first character was changed or not changed. So if we have flag as false, right? That means the first was never changed, so we change the second one. If flag is false, okay? We change the second one, that means we're increasing an operation. We're increasing an operation. And we set the flag to true because the second one is changed now. If the flag was already true, that means we are not doing any new operation, we change that itself. So which we won't increment the answer, but we should set the flag to false, because next time if you go ahead, like if you have to correct right aim here, if you're changing this one again, now when you move ahead, so this one is never changed, right? So we set to flag as false because this one is not changed. If you're changing this one, we set the flag to true. In this the first case, right? When the flag was false, so we change this one. So we set the flag to true. You got my point. Okay. So yeah, basic question. A good one. If you want, we can code this because people may have doubt here. Okay, fine. Let's quickly code this. We set the flag to false. Initially, int answer to 0. You can iterate on the string for int I equal to 0 to where? I just then word dot size minus 1 I plus plus. What we should do? We should check whether they are almost equal or not. If word of I is equal to word of I plus 1, or basically you can just check the absolute difference, right? If absolute of word of I minus word of I plus 1, right? If the absolute difference, right? It's less than equal to 1. That means they are almost equal, right? So we check the flag. If flag was already true, that means the first character was already changed before. So what? So we won't increment the answer because that was already changed. We changed it again. The answer is not incremented, and we set the flag to false. Yes, we change the second one. So we change the set the flag to true. Okay, and the answer will be correct. And because we're changing the correct now. Right? And this is fine. I think this should work. Basic code. If you have any doubts here, right, you can just rewind the video and watch again. For the people who are watching it on YouTube, I believe, right? That's correct. I think the absolute operation did it wrong, maybe. So here, if you see manually biologic A, and A, so we should change the second one, right? We change this one, right? Now going ahead, A and C, they're not almost equal. Going ahead, C and B, they are okay. One case we have to right. If they are not almost equal, right? Then then the fact should always be what? False, because if two characters are not almost equal, that means you are not changing anything, right? Let's say find it here. What I'm seeing. This is fine. Yeah. So we are seeing, right? Let's say if we are here A, B, C. Let's say A, D, C. Okay. Now let's say here we had flag as true. Now we checked A and D. You showed they are not almost equal. You go ahead, right? D and C. But here the flag should be false, right? Because we have not flag is true when we have changed this correct. We have not changed it. So why should the flag be true? We should set it the flag to be false every time, right? When they're not almost equal, we are not changing anything. The flag is false. If we are changing any fresh character, then we set the flag to true. I think we would over discuss this question, but yeah, fine. Okay, moving ahead to the third question, or probably the last question of the day. You are given an integer array num and an integer capital K, small k. The frequency of an element x, the frequency of an element x is the number of times it occurs in an array. Fine. An array is called good if the frequency of each element in the array is less than or equal to k. Fine. Return the longest good subarray of num. Okay. What this question is clear, right? The frequency of an element x is the number of times it occurs in the array. An array is called good if the frequency of each element in the array is less than or equal to k. Okay, fine. Let's say this is an array. Okay. If we consider this entire array, right, is it good or not? How to decide? In this array, how many different elements are there? One, two, three. We have three different elements. What is the frequency of one? One time, two times. So one occurs three times. The frequency of one is three. What is the frequency of two? One, two, three. Again three. What is the frequency of three? Two times it occurs. So is the frequency of each character less than k or equal to k? No. So they have more frequency. So what? This is not a good. This entire array is not a good array. We want to find a sub array of this entire array. Such that it is good. Such that it is good. And by brute force we can do, right? Brute force we can iterate on all the sub arrays, right? Just one, two sub array. We can iterate. Then we can check whether it is good or not. So check we need O of n time, right? We can iterate, count the frequency of each element. Then we can check whether the frequency of each is less than equal to k. If it is less than equal to k, that array is that sub array is a good one. So we can do this for all the sub array. And I think if we do this for all the sub array, it would be quite costly because it will be an cube, right? So there are n square sub array of an array, and here we have permitted only n type because n is 10 to the power 5. So we have to do in O of n how to do. So yeah, let's think a bit and we solve this question. Okay, so like let's open for discussion once. Okay, I'm unmuting you all. Okay, so any approach, Ashni, how to do? It's a basic question, right?
Yes, sir. Yes, we are. मतलब we can use sliding window basically to
Yeah,
check अगर n जब भी कोई एलिमेंट का वैल्यू अगर उससे ज़्यादा हो रहा है तो सिंपली इन द while loop we will iterate whenever till the value of that particular element is less than frequency or not.
correct. So this is quite a basic question. We discussed the same question many times in the mapping series, and every series we have discussed this question. And this is quite a common question which occurs in every contest, right? So if you can see the board, that let me know. Okay, fine. You can see the board, right? Okay, see. Okay, I think yeah, I can read the chat. Okay, fine. Okay, so it's a basic mapping question, right? Let's start like this, right? Let's take the. I will again request you, if you are new to this type of question, you can watch the hashing series, the fourth and the fifth video. We'll discuss this explicitly in detail. I'll again go through it in a short. Say, so let's say we have a map and we start from here, right? We start off somewhere from here. We go on counting, right? So map of one is one. Going ahead. Map of two, one. Map of three. Map of one again is increasing two. Map of two again is two. Map of three again is two. Again going ahead. What happens? Map of one becomes three. Now we know this is our case two. So one element has become irresponsible or he is not able to accommodate in our subarray. So what you should do? You should make our subarray to accommodate this element. Now before doing that, so till here, till, till we came here, till here it was fine. So our left pointer is not indexed this one. Our right pointer is at this index. So this was a good subarray till here. Let's let this fix till now. We have a six good subarray. Now we have to adjust this element, right? To adjust this element, we have to reduce this pointer so that we can adjust this element. So here it's one. So one here, we have one here. We remove this one because we are moving our left pointer forward, right? So moving one, this makes it two again. Now this is adjustable, right? Now going ahead, now we can move the right pointer safely because our left pointer is adjustable position now because now every element in our map is having a frequency less than or equal to k. Now moving this ahead, map of two again becomes three. Now this is again a problem because no element can be greater than k. So now, now what we can do? Okay, so we can here to here it was a good array. Now it's not a good one. So what was the length? From here to here it's six again. So we can take maximum of length comma current length and six comma six maximum is again six, right? Now going ahead, like now what's our job to remove the element to make this array compatible? How can we make it compatible? We have to reduce one to we reduce a left element, right? This is two. This is fine. I think this sounds good, right? Similarly, we can proceed. And if you see the example right here, yeah. So let's take a rough example once more. Be very clear on this fact. Okay, let's say case one. So what should we do? So what should we do? Map of one is one. Map of two is again one. Our left pointer is here. Map of three is one. Again, map of 2 becomes 2. Now this is a problem. This should not be done. So till here, we have a good array. And this 3. Uh, Now going ahead, 2. Now we have to remove a 2 or we have to make it adjustable. How should we make it adjustable? To remove element from the left until we make it adjustable. So we remove this one, 1, 0. Now going ahead, 2, 1. 1 is 0. If equals to 2 is 1. When 3 is 1. No, it's fine. It's adjustable because our problem was with this extra 2. We removed this 2. Now it's adjustable. So our left pointer is here. Now we can continue moving the right pointer. 4, 4, 3 to 4, right? Now going ahead, we have no more element. Now we have a length. We can update because we have finished with the array. We have finished with the array. Length 3. We can update again. 3 comma 3. So our answer is 3 in this case. I think this question is quite clear. You can code it, right? Let me open the mic. If you can say, you can code this question, right? Okay, I think, yeah. I can read the chat, it's fine. Let's see the last question. If it is solvable for us in this class, as we can postpone it to the next class. Yeah. So currently reading the fourth question. Yeah. So yeah. There is a company with N branches across the country, some of which are connected by roads. Initially, all the branches are reachable from each other by traveling some road. There is a company with N branches across the country, some of which are connected by roads. So this is a graph question. Initially, all the branches are reachable from each other by traveling some roads. So this graph is a connected graph, right? If you can reach from one component, you can reach all the components, then the graph is connected one. The company has realized that they are spending an excessive amount of time traveling between their branches. As a result, they have decided to close down some of the branches. Okay. However, they want to ensure that the remaining branches have a distance of at most max distance from each other. Okay, fine. The distance between two branches is the minimum total travel. Fine. You're given integer n, max distance, and a zero next to the array roads. Fine. Yeah. Return the number of possible set of closing branches so that any branch. Okay, fine. I think this question is clear. Let's discuss with an example. Okay, so this one, right? So this one is our, they have 3/4 of the company, 3 branches, right? And they're connected by this road, right? And this is the distance, right, between them. Correct here. Let's see. Max distance 5. Now 0 and 1. So we have to output what? Return the number of possible sets of closing branches so that any branch has a distance of at most max distance from any other. Okay, fine. Okay, so it is return the number of possible set of closing branches, right? Let's discuss every case, okay? If it is like what are the possible set possible, right? Set basically 0 is a set, 0 1, 0 2, 1 2, 0 1 2. and 1, 2, and empty set. So we have total 8 sets possible, right? Out of this, which are feasible set, right? If we have that set of branches, the distance between any two branches will be less than the max distance. We have to find out. So let's consider this set 0. So if we have only one element 0, right? Only one road 0. So if we have only one branch, in any case, if we have one branch, then distance between that branch to all other branches is 0 because we don't have any other branch. So all these are acceptable, right? Which one? All these are acceptable, right? Fine. Now let's say we discuss this 0, 1. So if we have 0, 1, right? 0, 1 has this one, right? This structure. This 2 is not there, so these two roads are not there. Any road connected to 2 is cancelled. So the distance here is 2, which is less than our max distance 5. This is acceptable. 0, 2. 0, 2 is this one. Now here the distance is 10, which is greater than 5. This is not acceptable. 1, 2. Again, distance is 10, is greater than 5. Not acceptable. 0, 1, 2. 0, 1, 2, this one, right? Again here also 0, 2, 10. 1, 2, 10. Again, this is greater than 5. 1, 2, 3, 4. And this one is empty. 5. We have 5 possible sets so that they are adjustable within the limits of max distance. Okay, let's discuss one more case here. Okay. Now, see, one thing the question says that there can be multiple roads between two. So we should always take the road which is less distance, right? Like 10, 20, 30. Let's say we have three roads, right? So we should, which one we should keep? 10. Obviously, now see here. Here max distance is 5, correct? Now, again, we have 8 sets, right? And we can check on all the set. And I think in this cassette, if we check on all the set, only the set which is unacceptable, I believe, is this one. If we keep only the set which has 0, 1, right? That is not acceptable. As all the set is acceptable. Let's say you set take a set 0, 1, 2. Okay. So if 0, 1 distance is 2, 0, 1 distance is 10, not 10. If you go via 2, right? Then distance is 4. 0, 2 distance is 2. Fine. Now from 1 again 0 is 4. 1 again 2 is 2. So if you take any two road, your distance less than max distance, so that is acceptable. Hmm. So I think the question is quite clear. Okay. Sounds good, right? Is the
हाँ भैया.
question clear? Okay.
हाँ
So here
clear.
the question is still that again we have to consider all the sets and we have to take all the set. We have to take those sets which are feasible. How to check whether the set is feasible or not? If the roads present in that set are reachable from any other road,
Reachable.
right?
Hmm.
So first of all, one basic thing, right? You have n is 10, right? N
And
is 10, right?
n cases will always be there.
So
N
so
sets.
how many subsets are possible?
Subsets 45.
20
हाँ हाँ. Oh, subsets to be part है. I thought subarray.
correct?
One.
1024, right? So we can consider all the subsets. So we have a
Ah,
basic permutation combination, right? So we can make all the subsets of a given set,
subset.
right? So if we
Mm-hmm.
consider all the subset, now for each subset, what is the issue? We have to solve this whether that subset has all the roots which are reachable between the maximum distance limits, right? How to check that?
Mm-hmm.
So like let's say we have a subset, right? From that subset we can make a graph. For example, let's say take an example. Okay, if we have this subset, right? Okay, so let's say we have a subset here, 0, 2. So what we will do, we consider a graph which has only 0 and 2. If we see this road has 0, 1, right? Is this a road
Mm.
possible? Because 1 is not there now set. 0,
No,
1,
no.
not possible.
Mm.
1, 2, yeah, this is a road not possible again. 0, 2, yeah. So we have to, this is our final graph. So basically our point of saying is you have to first construct a graph which has the given node that is present in the active set. Correct?
ठीक है.
Yeah. Okay.
लेकिन
Now, now
roads
see,
don't like हाँ.
yeah. Now see. So we have total of how many roads present maximum?
Then
Yeah. So yeah. So 1,000. Okay. So we can iterate on this, right? And we can find all the roads which are say now set. Correct. After finding all the roads, we can construct a graph. Now our question freezes down to what? We have a graph, right? We have a graph. Yeah. We have a graph. Graph has all you have to find if the minimum distance between find minutes in all roads to do less than the given distance. Okay. Clear?
mm.
So our what's our task? We have to because it's completely within our time limits, right? Because if we iterate on all the subsets, we have 1,000 subsets, and for each subset, it's maximum again 1,000 iterations, right? So 10 to the power 3 number of subsets, and for each subset, we iterate 10 to the power 3 times, right? So it's within our time limits, right? So we have to find a way in which basically a graph at max which has 1,000 nodes, right? We have to find in this graph in overfit complexity whether it is possible that all the minimum distance between each other is how much less than
Common.
the given. Correct. Now what should you do? If you will discuss the algorithm, right? Let's discuss on each algorithm. We'll discuss the work here.
The
We'll dis
Dijkstra, no, because
why?
the Dijkstra, the Dijkstra will only give the shortest between, uh, only, it will not consider all the
This
nodes.
cluster algorithm gives the shortest distance from a node to all other nodes, right?
It will give the shortest distance.
So what do we need here? We need to find the distance between all the roads, right? We have to minimize the distance between all the roads, right? So that's what possible we discussed. Any other approach which you can use here?
Um, One such is the extension of the Floyd Warshall where we pass through all the nodes.
Okay, let's discuss on the third version. Okay, do we discuss do we solve okay in the third version method what's the complexity of the third version method?
But it will be Floyd Warshall is n square.
So I think 2 to the power n into n square is not acceptable, right? Because the n can be at max 1,000. Okay, sorry. Yeah, it's totally acceptable. This was an easy question then. Huh. N is at what's the maximum value of n possible? 10, right?
10.
At max, we
Fraud
can have
partial
10
is
nodes.
actually
Yeah.
an cube, I think.
So it's fine. See, we have many methods, right? For Gaussian and other algorithm which can calculate, or else we can use discussor multiple times. Not an issue. Why? See, at okay, we have 1,000 sets, right?
For each node, we can
In
use
one
the
set, how
Dixon.
many nodes? In one set, how many nodes we can have? 10 nodes at max. The worst case, we can have 10 nodes, right? Am I correct?
10
Okay.
max.
Okay. Let's say, okay. So, if we construct a graph, right? So, in between two nodes, we always have one edge. Why? Because if there are multiple edges, let's say we have two nodes, one and two. If there are multiple edges, right? We always consider that edge which has the minimum distance, right? That's obvious.
Uh,
Because so if we construct a graph, right, and we use discussor on each node, let's say we have 10 nodes. So we use discussor on node 1. So discussor on node 1 means we find the distance between node 1 and all other nodes, right? We find the
okay.
distance between
Mm-hmm.
node. So it will take of n log n time, right? And is 10 here, correct? So if we use
And log
discussor on
it, huh?
discussor on all the nodes, right? We have n nodes, right? We have n nodes.
So
So
n,
for one
n
node it's
square
n
log
log
n.
n, so n square log n, which is
Mm.
completely acceptable. So to our complexity is 2 to the power n into n square log n, correct?
Acceptable.
So n is 10, right? So it's 10 to the power 3 into 10 to the power 2. 10 to the power 5 log 10. It's totally acceptable, right? No issues here.
Mm.
So it's just about writing the code. So first you have to use PNC or a basic bit manipulation, bit masking, or anything you want to use. You can use to generate all the subsets. And then for each subset, what you should do for each subset, you should apply discussor on each, right? That's the best approach I would use. As I think fraud version can also be used. It's also the same complexity and square, but generally people are accustomed to use discussor.
The extra.
Okay, and that's why
Only
they have
log
used
n is
complexity
extra,
in
so
such a way.
not much difference.
It's fine. And
Mm.
because 2 to the power n into n square is 10 to the power 5 anyway. It's totally
Mm-hmm.
acceptable. So yeah. So this was also a good question. It's all about coding the approach. That's it, right? So I think yeah, this was quite a good contest. Like yeah, this contest gave detailed insights on different topics.
Mm.
Like